Hi everyone, Assalamualaikum warahmatullahi wabarakatuh. In this video, I will be giving you examples that are related to graph sketching. And if you look at this example here, example 6.17, this is actually similar to what you have seen in the previous video, except that here we are dealing with a different function. And I'm sure that you remember the shape that is associated with this function. This is a very simple V shape. And perhaps in this video what I'm going to do is I will just demonstrate to you the first modification to the original function that you have here, and the rest of it I will just leave it to you guys to do it on your own. Okay, let's start off by drawing the axis. So this is my vertical axis, and this could be my horizontal axis. So now I'm just going to take care of the scale. Okay, perhaps until 5. So here -1, -2, -3, -4, -5, and on top here is 1, 2, 3, 4, 5. So basically when you have this function, it is telling you that if you have whatever value of x, you plug into this function, then this function will return the same value as x, except that the function makes it positive. So for example, here if x is 1, you will get 1. X is 2, you will get 2. -1, you will get 1, you make it positive. -2, you will get 2, and so on. So I'm just going to continue plotting the dots. Okay, so this could be my line here on the positive side of x. Could be somewhere here. Okay, so my graph may look like this. Okay, it looks, well, not bad. Okay, next is I'm going to continue with sketching this function. So basically, this is about when you have 2 inside the function, inside the original function. So this is about horizontally compressing the function. So I'm just going to write it down. So this is horizontally compressed. The function, the original function. This is the original function. It will be horizontally compressed. You can imagine having this point here going inside. Everything will be compressed horizontally. So this one will also be going inside. Okay. Now I'm going to start choosing or selecting points that will be helpful in sketching the graph. So the first one is I'm going to start with point 0. So if x is 0, this function is basically saying that I will be having y absolute value of 2x. So if x is 0, I will have y equals to 0. And maybe I'm going to choose point x equals to 3. So you can see that when x is equal to 3, my points here will be actually at 6. So this may be 6. So maybe somewhere here. And similarly, if x is -3, so the points here will be somewhere here, -3 and 6. And so I should be able to sketch my graph. Okay, the new function, the new modification to the original function here. So it will be somewhere here. So I'm just going to draw a solid line now. Okay, so there you go. That's my new function where fx, this is equal to absolute value of 2x. Right, now let's look at the second example. So this one. So this is basically saying that you are going to horizontally stretching the original function. So this is horizontally, okay, stretch. Horizontally stretch. So the original graph here will be horizontally stretched with factor 1/2. So basically the function that I have now is y is equal to x over 2. So if I start with point 0, y will also be 0, it will be here at this point. If let's say x is 4, then y is going to be 2, so it will be somewhere here. So meaning when you say that it is horizontally stretched, it means that this original graph is being stretched outward. So it is being stretched outward. So this one is also being stretched. Okay. So now similarly, if I have -4, -4/2 is -2, modulus or absolute value of that will be 2. So it will be at this point. Okay, so now I can actually sketch the new function here that I have. So it will be looking like this. Okay. All right. So I trust that you can do this on your own. And so with that, I'm going to move to the next example, the last example of this chapter. So here, this is about combining all the information that you have seen in subtopic 6.6, and we are going to sketch a graph of a function that looks like this. Okay, so when you get a complex function, okay, such as -2 multiplied with this x minus 3 squared plus 1, what you should do is you should start with identifying what's the basic function. Okay, so based on this, the basic function as your starting point will be y equals to x squared, because here you have square, you have some value of x over here, so the starting point will be x squared. And by sketching that, this is what you have. So y equals to x squared. This is the function that you have. This is how the function looks like. Next, what I'm going to do is I can introduce -3 to the original function here. So now I'm going to add on y is equal to x minus 3 squared. Okay, so the function will be looking like this, where the original function here, the function that I have here, will be shifted 3 units to the right. So so this will be shifted to 3 units to the right, so maybe somewhere here. And then based on this simple equation, I think you can determine where the curve crosses the y-axis. So it will cross it at 0.9. Yeah, when y is when x is 0, when x is 0, y will be equal to 9. This can be easily determined by plugging the value of x equals to 0. So here it will cross at 0.9. So this is how the graph looks like. So this is at 3 and 9. Yeah. So okay, next step is step 3. is I will introduce factor 2 outside this function. So factor 2 outside this function. So I'm going to have y is equal to 2 x minus 3 squared. So my graph will be actually vertically stretched. Okay, so my graph will be vertically stretched. So it looks the same. This is still at 0.3, but the intersection with y will be at a different point. So here, if you see, if this is originally at 9, for this one it will be multiplied with 2, so this will be at 18. I hope you get the idea. Okay, so the next step is I'm going to introduce the negative sign outside the function. So step 4, I'm going to have the negative sign outside the whole function, where my whole function is 2x minus 3 squared. Okay, so this is saying that the graph here, the purple graph here, will be reflected along this x-axis. So my graph will look like this. Okay, so this is could be 3, this could be negative 18, so it may look like this. Okay, and finally, after I'm done with that, I'm going to introduce I'm going to have to make the graph move 1 unit up. So finally, I'm going to have the last step here is negative 2 x minus 3 squared plus 1. So this green graph here will be moved 1 unit up. So if I sketch the last graph, this is how it will look like. So negative 18 will be at negative 17. 1, 2, 3. So this is 3. This point here will be moved to 1. And so this is how it looks like. And you should know that the point here, okay, the point where the roots of this equation will be at 3 plus minus, so 3 plus minus square root of 1 over 2, which means that this point is 3 plus sec 1 over 2, and this point is actually 3 minus sec 1 over 2. Okay, so that's the end of chapter 6. Thank you very much for watching. I'll see you in the next video.